Hello all. Welcome to this tutorial. In this video, we're going to see about the experiment feature selection and extraction. Where we'll go into cleaning, selecting, and transforming features from a data set, and we go cell by cell explaining the code and what the output tell us. So first, we're reading the data. We load our data set first, and then we read the data, and we import pandas for data handling and numpy for calculations in numbers, and then we're dropping specific columns like we're dropping chlorides and fleece sulfur dioxide right there, and we drop and we check the shape of it. So after dropping those two columns, how many rows and how many columns are there, and then we're detecting and dropping outliers, and we copy the data frame to a temporary data frame, and to avoid messing up the original the copy that, and we then loop through each for hunting outliers using the IQR method. So Q1 is the 25th percentile, and the Q3 is the 75th percentile, and IQR is the difference. So we find the lower bound there, and if any values fall outside, we flag that column, and next we're going to and dropping low variance columns where we drop variance and like under 0.5. So why we doing this is because low variance means does not change the features much, but for prediction they add noise without signal. So that's why we're dropping those low variance columns, and we're finding the low correlation columns, correlation to the target. We computing the absolute value, so negative links counts 2. We filter the less than 0.1 there, and we exclude the quality itself. So features are weakly tied to quality, and it won't help predict our score. So we use the built-in function absolute to catch relationships which are inverse. And next, dropping those low correlation after finding out the low correlated columns, we drop it because to make a feature set predictive, we drop those columns. And next, we find the pair of highly correlated pairs. We dropping the quality column, and we getting the absolute of the correlated matrix, and we're setting up the range like 0.65. So 65% highly correlated features redundantly explain the same thing, which causes the model to be unstable. So we exclude the target to focus on the inputs. And eighth one, what we do, we're dropping those high correlated ones. Previously, what we did was we're dropping low correlated columns, and then we drop high correlated columns, and then we separating the targets X and Y. X is DF without quality, and Y is just quality, and it preps for modeling X for inputs and Y for outputs. So next, we performing a univariate selection with the method called select k best. So we are importing select k best and chi square from sklearn, and min max scalar for negative no, sorry, for non-negative scaling, and we select scaling X and selecting the top 5 chi square score features, and we measure the independence of the targets. And cell 11 here, and the question 11 says about mutual information score. So it scores the dependency between features and Y. It turns into series and sorts descendingly. So next is PCA, which is called principal component analysis. We just do just principal component analysis. We don't need any import libraries for it. So what we're doing in this principal component analysis is that we center X by mean. We center the X targets by the mean. We're computing the covariance matrix, eigenvalues and vectors, and we're sorting and taking the top two vectors as a centered dot. So it rotates to max variance axis. First two components gets the major most spread. And 13th question just says about LDA feature extraction. which is linear discriminant analysis, where we do, unlike PCA, unsupervised. It maximizes class separation for quality levels, and it is great for classification. And last but not least, we're doing uh, image display, and we're doing image feature extraction. So in order to do the image feature extraction, we import CV2, NumPy, Matplotlib library, and we're loading an sample picture into it, and we computing pixel wise mean for across channels for grayscale mean feature. So by doing pixel by pixel mean feature, we infer to know that mean collapses color to intensity and reduces dimensions while keeping the structure.